Hello, this is Mrs. Sharp. I wanted to record a quick video here to go through some of these notes with you. If you would though, first of all, if you don't have Unit 1 Lesson 5 out, pause the video. And also if you would pause the video and jot down the learning target, I can evaluate a function using function notation. So go ahead and pause the video. When you have that written down, come on back. Okay, I want to just quickly go over the first section here, which you hopefully already did as a warm-up, but I just want to reinforce how to interpret this notation. So as you see here, right here, we talked about the way you would read this is f of x. So I'm going to write that over here to the side, f of x. So f of x, which is a function, is equal to x plus 2. So what this is saying is, let me switch over to a highlighter here. The number in the parentheses in place of x is the number that we substitute in place of x on the other side of the equation. So again, it's another way of saying y equals, oops, sorry, let me fix that. It's another way of saying y equals, but it's a more powerful way of helping us remember the input. So when I look at the first example here, this is basically saying, oh gosh, I'm sorry, I keep touching that. It's basically saying when x is equal to 4, what does the function equal? Well, if you plug 4 in for x, 4 plus 2 gives us the 6. Okay, so the 4 and the 6 give us the input and the output. So when x is equal to -1, so if you plug -1 in for x and go through the expression, we get 1. When x is equal to 7, if you plug 7 in for the expression, we get 9. Okay, so this is really an input-output notation, an input-output way of writing things. So what we have below are just two examples of how to evaluate these functions. So again, when I look at this, the number in my parentheses represents the number I'm going to plug in place of x. Now, I also want you to notice here, I have two functions. I have one that begins with f, and I have one that begins with h. You need to really pay attention to which function you plug in for. So if you look at part A, it says f of 2. So I want to plug 2 in the function that begins with f. Whereas letter B says h of -3. I'm going to ignore the f of x function and just work with h of x. All right, so if we do the first one, f of 2. So I only want to focus on the f of x function. Okay, so I'm going to take the number in parentheses and plug it in place of x. So I'm going to plug 2 in place of x. So 12 minus 3 times 2. Order of operations, we would do 3 times 2 first, which is 6. And then 12 minus 6 is 6. So I could say that f, oops, lost my pens. Oh goodness. Hold on. Oh no. Oh, you know what? I think I know what I did. Oh my goodness, they're back. All right, let me get back here. So what I could do is I could say that f of 2 turns into a 6. When I put 2 in for the input, I get 6 for the output. All right, so 6 is my answer. So pause the video and I would like you to do part B. When you're finished, hit play again. Okay, so I'm working with h. I'm working with h of x. Oh my gosh, I got to figure this out. I'm so sorry. H of x equals 7x. All right, so I am going to take -3, substitute it in for x. So I need to do 7 times negative 3, which is negative 21. So h of negative 3 equals negative 21. Okay, so again, input was negative 3. Oh, goodness. I've created a mess here. Oh my gosh, I'm so sorry. Okay, the input is negative 3. Whoa, the output is negative 21. Okay, so function notation helps preserve input and produce an output. Okay, if you have any further questions, feel free to ask on Friday, or you're welcome to send me an email and we can chat more.